Alright, so today we're going to continue on with our unit. We just have 2 more lessons to go. For today, we're going to do some angle measuring, but I'm just going to use the protractor and then y'all are just going to help me measure to find these angles. We did the geometricity yesterday, and so today we're doing day 11. We're going to start by measuring and labeling each angle. So I'm just going to get out a protractor and we're going to measure. If we measure one of these angles in the intersection here, we can use the idea of linear pairs and supplementary angles to find the rest of them. Does everybody agree?
Yes, ma'am.
Yes. Okay. So let's say we want to measure angle A. So I'm going to line up. If I want to measure angle A, I'm either going to line up with the horizontally line. It's not really horizontal. The side-to-side line and the up and down line. I'm going to go ahead and go with the side-to-side line. And I'm going to put the vertex right at the center of the protractor. And I can see that when I line it up, if I'm trying to measure angle A, it goes out to 60 and then out to 120. So I need to know if we're looking at 60 or 120. So if I look at the other side, I want to look at where it goes to 0. Those are the outside numbers. So that means I'm looking at the outside numbers. So how big is angle A? 120. Which means the vertical angle is 120. What's the linear pair angle? 60. Okay, and we can fill those in here also. Just for time's sake, I'm going to leave them blank for now. Okay, so far so good. Let's do the other intersection. My other intersection, which angle do you want me to measure? E, F, G, or H?
E.
E. So if I want to measure E, I'm going to line up. I can either line up here, or I can line up here. Either way, it doesn't matter. But let's say I line up here. Just like so. Okay, and so when it comes out, it's going to hit between 80 and 85, and then up here between 95 and 100. So I need to know which one it is. So again, if I come out this way, I can see that the zeros are the outside set, so I'm using the outside set of numbers. So I need to zoom in so I can figure out where exactly I think that's hitting on the outside set of numbers. So this line right here, what would you say that is? 97? It's like 2 after the 95? We'll go with 97. That looks good to me. So if E is 97, then G is 97. What are F and H? 83? So that my linear pairs are supplementary, because linear pairs are always 180 when I add them together. Okay. All right. Next intersection. Down here, I, J, K, and M. Which angle would you like me to measure?
M and I.
M and I. We only need to measure one. I. You want me to put it like this, or you want me to put it like this?
Like that.
Like this? Okay. So if I put it like this, and I line it up, then, you're welcome. All right. So, whoops. Let's figure out which numbers we're going to use. So if I'm measuring angle I, when I come out I, make sure that's nice and lined up. I is right here, going to 0 on my inside numbers. So that means this time if I'm measuring I want to use the inside numbers. So where do you think that is? It's kind of hard to tell.
108.
108-ish. If you're not sure, you could always measure the opposite side, right? Yeah. If I'm measuring, oh, you can't see where I lined it up. I just flipped it over, and now I'm measuring angle K instead of angle I, just the vertical one to it, because I know the vertical one's equal to it. So if I'm measuring angle K instead, I start at 0, and I open up to angle K, which is going to be between 105 and 110. So I can look out here, that's 105. So what would you say that is? Oh, you can't see. this is 105. That line right there. What would you say that is? 107? If we round, it's probably really like 106 and a half. So we'll round it to 107. So I and K are 107. Which means J and M are what?
73.
73. Okay. Then the next one, what color should I do next? Let's do pink. N, P, S, and R. Which one do you want me to measure?
P.
P. So if I'm going to measure P, I'm going to line up here. P goes out to 0 on the inside numbers, so that means I'm using the inside numbers when I come out. So it's just in front of the 100. So the 100 up here is where the 80 is. So what would you say this is? 99? Okay. Which means N and R are how much?
81.
81. And I didn't preface it when we started, but would you agree that both of these pictures depict two lines crossed by a transversal? Yes. Okay. All right. Before we do the next page, I'm actually going to skip to this page that has the columns, the sideways. So I'm going to skip to the sideways page. And look, those are what we just measured. And we happen to get the same thing that I got digitally as well. Okay? I think, except for maybe that 96 and 84. Is that what we got? Did we get 96 and 84? Oh, we did 97 and 83. We were close. Okay? I think that's the only one we were 1 degree different on. We rounded up, they rounded down. All right, compare the vertical angles. What is their relationship? So when I look at all the vertical angles in my pictures here, what's the relationship? They're always, are they congruent or are they supplementary? They are vertical. What are they?
Equal.
They're equal, right? 120, 120, 60, 60, 96, 96, 84, 84. Vertical angles, you should know this by now. We've been doing this since the second week of school, or maybe third. They're across from each other when two lines intersect, so they are congruent. They're opposite of each other, so they are congruent. Okay. What about my linear pair, my two angles that make a line?
They add up to 180.
They add up to 180. What's a good geometry word for that? Supplementary. Okay. Identify the corresponding angles and their measures. Does there appear to be a relationship? So what does it mean to be corresponding? Do you remember?
The same.
The same position, right? Not necessarily the same angle. We're going to see right now if they're the same angle. So if I'm looking at angle A, which angle would be corresponding to angle A?
Angle E.
Angle E. One's 120, one's 96. Does it seem like there's a relationship there?
No.
Not really. If I look at any of the others, what about this one? 60 would match with what? No, that's a linear pair. What is the corresponding matches with the 84? What about this 120? It matches with the 96. And the 60 matches with the 84. So they're not, none of them are the same. Are they complementary or supplementary?
No.
Does it seem like there's any sort of relationship?
No.
If I check over here, I can check the same thing. The 107 and the 81, the 73 and the 99.
Both 120s equals 90 are 96.
Huh?
Both 120s are corresponding to 96.
Yeah. So they correspond to the same number. But there's no like geometrical relationship really, because over here, again, they would correspond to the same number, but there's not a geometric relationship that we could use to solve, right? If we needed to solve something. So we're going to say no relationship. Alternate exterior angles, let's look at those. So for alternate exterior, if I'm at this angle B that's 60 degrees, what would be the matching alternate exterior angle to that one?
84.
84 would be the matching alternate exterior angle. My 120 would match with the 96. My 73 would match with the 99, and the 107 would match with the 81. Does it seem like there's a relationship? No. No relationship. Okay. Let's look at alternate interior. So if I look at alternate interior, which one would be alternate interior to this 60 right here?
84.
The 84. What about the 96? 120. What about the 73? What about the 81? Are there any others? Did I get them all? I got them all. Is there a relationship?
No.
No relationship. Okay. So if I was going to use inductive reasoning to talk about the angle relationships between angles formed with transversals, and I saw no relationship, no relationship, no relationship, what would we think about for the last one?
No relationship.
Probably no relationship if I'm just doing inductive reasoning, but let's look and see. So if I do same side interior, I've got that other picture all marked up, so I'll mark this one up. I'll do a little asterisk. Which one's the same side interior to the 73?
81.
The 81. What about the 107?
99.
The 99. What about the 60?
96.
96. What about the 120?
81.
Is there any sort of relationship?
No.
No relationship. All right. So now I'm going to come back here. We're going to measure these. What's the difference now? I still have two lines crossed by a transversal.
They're parallel.
This time I'm going to have parallel lines. So now I've got parallel lines. How did you know they were parallel?
So they have the little arrows.
Right. These triangles here mean parallel, in case you forgot. Okay, those triangles mean that those two lines are parallel to each other. Sometimes you'll see little double triangles. We'll see that later in the notes. Same thing, just like if you see double tick marks, that means two lines or two segments are congruent. Same thing here. All right, so let's measure A, B, C, or D?
A.
A. So if I want to measure angle A, oops, I'm going the wrong way. Be able to see my protractor. When I put my protractor down and I measure and I go out, is that going to be the 120 or the 60?
60.
The 60. Couple ways we know that. We can use it mathematically like we did on the previous page where we said the other ray goes out to 0, so it's the outside set of numbers, goes to 60. Or you could inductively say, I know this is to scale and acute angles are smaller than obtuse angles, so it's got to be the 60 because this is clearly the small side and that's the big side, right? So if A is 60, what's B?
120.
What's C?
60.
What's D?
120.
Okay. You want to measure E, F, G, or H?
E.
E, I'm going to do it sideways so it doesn't get confusing with all my other writing on the other intersection. All right, angle E, if I come out here, the 0 is on the inside, so when I open up for angle E, where am I going to land at? 60. So angle F is,
120.
G is,
60.
H is, not least, let's measure I through S. You want to measure I, J, K, or M? I. How big is angle I? Is it 100 or is it 80? 80, because it's on the side that the zero is on the outside. So 80, which means J is 100, which means K is 80, and M is 100. All right. Next one. Which one do we want to measure? N, P, S, or R? R. Okay. If I'm going to measure R, how big is R? 80. So S is 100. N is 80. P is 100. Okay. And then we're going to do the same thing we did before. We're going to look at our vertical angles, our linear pairs, our alternate exterior, our corresponding, our alternate interior, all the things. Okay? So when I look at my vertical angles, what's their relationship?
Congruent.
Are they always congruent?
Yes.
No matter where I look at my vertical angles?
Yes.
Yeah, they seem like they're always congruent. Okay, what about my linear pairs?
Supplementary.
Supplementary, are they always supplementary?
Yes.
Yes. What about my corresponding?
Congruent.
Those are congruent. Are they always congruent?
Yeah.
Yep, here, and then I go here. Those are both 80, and then I go here. They're both 100. If I come up here, same thing, right? They're both 60. If I move to the upper right, they're both 120. If I move to the lower right, they're both 60. If I move to the lower left, they're both 120. What about my alternate exterior?
Congruent.
Of course, same.
Is it always the same?
Yes.
Always the same? Always the same? Alternate interior?
Congruent.
Congruent? Still congruent? Congruent? Still congruent? Okay, let's go fill those out. Okay, vertical angles we said are congruent. You can either write the word out, or if you remember, do you remember what the symbol looks like for congruent? Almost. It's the equals with the squiggle. Means congruent. So I can put that over here. So our notes are complete. Our linear pairs are
Supplementary.
supplementary. There's no symbol for supplementary. We just know they add together to make 180. We don't say they equal 180, right? We say they add together to make 180. We said our corresponding angles were
Congruent.
congruent. We said our alternate exterior angles were
Congruent.
congruent. And we said our alternate interior angles were
Congruent.
congruent. I forgot to look at same side interior angles, but if I use inductive reasoning, what would my answer be?
Supplementary.
If I use inductive reasoning, what would my answer be?
Congruent.
Congruent, 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 congruent. If I follow the pattern and use inductive reasoning, it would be congruent. However, are my same side interior angles congruent?
No.
No, what are they?
Supplementary.
Yes, they are supplementary. So that's a good example of inductive reasoning sometimes gives you an incorrect answer. And that's okay. You still use good reasoning. It was just the wrong answer. Okay? Are they always supplementary? Are they supplementary down here also?
Yes.
Yes and yes. So my same side interior angles are not congruent. They are
Supplementary.
supplementary. which means I need to come up with some sort of way to remember that that's the one that's different from the other three. The way I do it is I say, well, same side interior also has a second name. Do you remember what its other name is? Consecutive interior. So I just try to remind myself the one that has to be different and have two names because it thinks it's special is also the one that's different because it's supplementary instead of congruent. That's just the way I remember. If you can think of a better way, let me know. Okay, sometimes that's how I get my most interesting ways to remember things is when y'all come up with a way to do it. Okay, so here's how we apply what we just learned. First thing, you can only apply what you just learned if the two lines that are being crossed are what? Parallel. So if your two lines are not parallel, then there's no relationship because that other line moving and not being parallel makes those angles no longer have a relationship with the other intersection. Okay? So the two lines have to be parallel for all of those properties to hold true. It says to identify the type of angle relationship and then give the missing measure. Okay? So what's the type of angle relationship between these two angles?
Alternate exterior.
Alternate exterior. Very good. So that means they are congruent or supplementary. Which one? Congruent. So how big is this angle right here? 110. Okay. The next one to the right, what's the relation? Well, first, can we apply the relationships?
Yes.
Yes, because we can see there's double parallel symbols, which just means they're also parallel. Okay. What's the relationship between the 84 and the question mark? What type of relationship? Alternate interior. So what does that mean about them? They're congruent because I have parallel lines. So how big is my question mark angle?
84.
84 degrees. Okay. The next one, what's the relationship between these two angles? Same side interior, or you could say consecutive interior. Which means they are congruent or supplementary? Supplementary, so I know they're going to add together to make 180. So how big is my question mark? 80. Okay. Then, last but certainly not least, what's the relationship between these? Corresponding, good. Which means they are congruent. They have equal measures. Good. So if one's 53, the other is 53. Easy peasy. Sometimes you'll have some algebra involved, but that doesn't really make it any harder, I don't think. When I look at this one here, it says, what is the relationship between the given angles? What do we call this pair? Corresponding. Which means what? Congruent or supplementary? Congruent. That means they have equal measures. So that means this angle's measure, 11x minus 2, is equal to this measure's 75. Now I just have to solve for x. What do I do? Add 2 to both sides. $11x equals 77. Then what? divide by 11, division property of equality, and x equals 7. So what's the relationship? It's corresponding, which means they're congruent, so x equals 11. All right, and then the next one, what's the relationship between these two?
Alternate interior.
Alternate interior. So what's their relationship? What does that mean? Congruent. So that means the measure of one angle, 132 degrees, is equal to the other angle, x plus 39. 139. I wrote it so my x was on the left-hand side. I wrote it backwards of how I said it. Okay? How do I solve this one? Subtract 139. Subtraction property of equality gives me that x equals what? Negative 7. And when I get a negative, sometimes my alarm bells go off and I go, wait, we can't do negatives in geometry. We can't have measurements that are negative. The variable can be a negative as long as when I plug it back into the problem, I get a positive measurement. So if I plug that negative 7 in here, I do get a positive 32 for the measure of that angle. So it's okay to have a negative x as long as it's not giving me a negative measurement. Hopefully that makes sense.
Makes sense.
Okay, good. All right, and then last but not least, what's the relationship between these two angles?
Consecutive interior.
Same side or consecutive interior. And what does that mean their relationship is? They're supplementary, so they're going to add up to 180. So that means if I add the two angles together, they equal 180. So instead of saying they equal each other, I have to add them together. So one of my angles is x plus 109. And the other angle is x plus 89. And I know together they're going to equal 180. What's the first thing I have to do? Add like terms. So 1x plus 1x is 2x. 109 plus 89 is 198 equals 180. Then what do I do? Subtract 198, which is going to leave me with negative 18. So 2x equals negative 18. Then I divide by 2, division property of equality. And x equals negative 9, which makes my alarm bells go off. So I just want to make sure when I put that in, it's going to give me positive measurements. Negative 9 plus 100 plus 109 is 100. Negative 9 plus 89 is 80. 180 are supplementary, so I feel confident that I did it correctly. Okay? Again, this only works if you have parallel lines. If you don't have parallel lines, these rules are not going to apply, right? Because there was no relationship when the lines weren't parallel. Okay? Your assessment is available for you in Schoology.